Hello everyone. Ooh, ouch. We're taking a look at our 3.7 lesson practice. So we're going to be doing some practice work on our measures of center. So a measure of center, as we talked about, is a single number that summarizes all of the data in the set. We have two measures of center that we look at. We have our mean and our median. They are typically used to describe a data set. The mean is the average, the median is our middle number. So you can check out this lesson summary, just kind of going through how we find those values. And then at the bottom, noting that when you have extreme values that are really big, much larger, or much smaller than the rest of the data set, we're going to notice that our mean is going to be pulled in that direction. So if you're all set and ready, push ahead to slide 2, where you're looking at the mean and the median of each of the data sets. So to find the median, we put it in order from smallest to greatest. And we cross off numbers on the left and the right to get our middle value, which of course here is 30. And then if we add them all up, 27 plus 30 plus 33, we get 90, and divide it by 3 numbers, we see our mean is also 30. So this one has a mean and a median that is the same value. Beautiful. For the next one, we have a 0, and then we have 4 100s. So to find the middle value, we're going to cross out on the left and the right until we get to our middle value of 100. And if we add all these up, we get 400, but then we're dividing it by 5 because there's 5 data points. So notice, like, it's really common that the data is 100, but then we have this 0 that pulls the average down to 80, and our median is 100. Last one, we have 3, 5, 7, and 15. As we're finding our middle value, we notice we get 2 numbers here in the middle. So when that happens, we add those 2 numbers up and divide by 2. 5 plus 7 is 12. 12 divided by 2 is 6. So our median is 6. Our mean, if we add all of these up, 3 plus 5 plus 7 plus 15 gets us 30. Divided by 4, because there's 4 numbers, is 7.5. Beautiful. So you should have this all filled in, and once you're all set, you can push ahead to the next slide. 7 people estimated how many marbles there were in a jar. Determine the mean and the median. I'm going to have you do this one on your own. Put the numbers in order from least to greatest, which actually, oh no, they are not. So you can use your whiteboard tools, write them in order from least to greatest to get your median, and then find your mean by adding them all up and dividing by 1, 2, 3, 4, 5, 6, 7, because we have 7 data points. So take a second, pause the video, and work through this one on your own. Remember, you can use the calculator built right in. If you click that button, it'll pop up on the right, wait, this way, on the right, over there. And when you're all set, push ahead to the next slide. Slide 4 says, here's a dot plot. This is a uniform dot plot. We see them all just in that one line. If we added 4 and 9, which statistic would change? So right now we have 1, 2, 3, 4, 5 6s. Right? So right now, the mean is 6, and the median is 6. Right? The middle number is definitely 6 because all the numbers are 6. Same with the average is 6 because all the numbers are 6. So if we add in a 4 and a 9, let's see how this changes. Well, first we can look at the median. Cross off one on the left, one on the right, and when we do this, we will still have a median of 6. That will stay the same. Now if we add them all up, 4 plus 5 6s plus a 9 is 43. And we're dividing that by 7. And our mean, after we added those values in, is 6.14. So we can see our mean changed. So since the total value and number of points would change, the mean is going to change too. So the total value and number of points changed, so the mean will change too. The median is staying the same because we're adding a number that's higher, which is our 9, and a number that's lower. So the middle value will be the same. Beautiful. Alrighty, get that plugged in and then push ahead to slide 5. Create a dot plot that matches the description. We want a median of 3 and a mean bigger than the median of 3. So this is going to give us a median of 3, right? 3 is in the middle. If we want to make the average bigger than 3, then we're going to want to add some data points out far away to the right. So let's see. Now if we add all these up and divide by 10, or sorry, by 4. Wait. 1, 2, 3, 4, 5. There we go. Now our median is 3, but our mean is 4.4. So this is just one example. It could totally be different. You know, you can add more points, play around with it, but then test out that your average is bigger than your median. So for this one here, let's try it, see if it works. 4 plus 4 plus 5 plus 2 10s is 47. And we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get 4.2, which is again is bigger than the median, which is actually the median might not be 3 at this point. We might need to add more 3 values in there to get that median to be 3. Let's see. So this has 5 3s, 2 4s, a 5, and a 10 to get 43. 8, 9, 10, 11, 12, and now we're dividing that by 12. That's 3.58. So that's bigger than 3, and here the median would definitely be 3. So to definitely make sure that the median is 3, you might want to have a lot of numbers in the 3 column so that 3 is your middle value. That's just a little tip. Your graph, like I said, might be different, but just make sure that you are fitting those qualifications and then push to the next slide. This one wants us to make a dot plot that matches the description, which is bell-shaped with a median of 6. So we want our middle number to be 6, and we also want it to be a bell, something like this. This would be bell-shaped with a median of 6. Bell-shaped kind of, goes up and comes down. So we see that rhythm here. And if we were to cross numbers out to get to the middle, because we have it balanced, 6 would definitely be our middle median value. Beautiful. Slide 7 says, for the past few weeks, Amanda kept track of how long it took him to do the dishes each night. Or Anand, not Amanda. This histogram shows the result in an organized 5-minute bins. So we see, right, the first bin is from 0 to 5 minutes, and then 5 to 10 minutes, 10 to 15, 15 to 20, and so forth. Choose the bin that is going to have the median. So we don't know what the exact data points are for this graph. Like, we don't know. This is 0 to 5. This could be a bunch of 2s, 2 minutes, or it could be 3s and 4s and twos and all mixed up. So we don't know exactly what the data points are, but we do know that there's 9 data points in this first bin, 3 data points in the second bin and the third bin. This has 4, and these each have 1. So all together, if we add them all up, actually let me use my calculator. If we add up all of our data points, oh, I hate how it changes that. Hold on, let me fix it. So we had 9, 3, 3, 4, 1, and 1.